It is exciting. So, hey Gert, how's it going? I'll wave at the camera. Camera's in a fairly odd position, but that's alright. So, I'm somewhat of an excuse to show off some parts of the runtime system, but there's a few things that need doing here. What I want to do is implement closures within Plasma and then build the module system on top of that. But that involves changing the way the existing module loading and code loading works within the runtime. So that's what I'm doing. And I think it's actually a really good example to look at because we'll see how the interpreter works, how the bytecode interpreter works. So, oh, lunch break-ish. Cool. I'm glad. So it's 9 PM here in Australia and lunchtime in Europe, in the Central European time zone. So that's nice. Obviously, we can't make everybody happy, particularly that I'm in Australia. So, what I eventually want to do, I'm going to look up, actually, I'll close that window, I'll open pz code. Yeah, this one. So what I eventually want to do is move the code. Once the code is loaded, it is put into the module structure. Each module gets given one of these structures, and all the bytecode, once loaded, is loaded into this array. And the data is likewise loaded here into the data field. What I want to do is move both of those, so make the data is already kind of individual data items, but the code, I want to make it individual data items. So I want to move this code pointer and have one per procedure. Right now when the code is loaded, each procedure is loaded one after the other into the code area. So what I want to do is have it just wherever it lands in memory, wherever malloc says it lands, and have it pointed to by the procedure. To do that, I have to change the way calls work within the bytecode so that when you see... Oh, the stream's lagging. Stream is not so healthy. Well, I hope we have enough bandwidth for this. See how we go. If we're having trouble, I'll have to do something else to reduce the bandwidth. Yeah, so I have to change, because right now a code location within the loaded bytecode format is an offset into the code area. Because the code area won't be contiguous anymore after this change, I have to first change the way code pointers work. So I wonder just how much trouble I'm having. YouTube. I'm just going to read these diagnostic messages because obviously there's some trouble. Stream health is excellent. The stream's current bitrate is lower than the recommended bitrate. We recommend, yeah, well, that's all the bitrate I can afford. Ah, so that's it's making it orange because I'm not transmitting a very high bitrate stream, but that's all the bitrate I can afford here. So is the stream working? Okay. Alright, so it's not being exactly live, but alright, we'll see how we go. Sorry about that. So yeah, so I don't want to change this now. First I want to change how code is loaded. To talk about that, I want to pull up pz read. This is how we read the bytecode in. Now there's the on-disk bytecode format, and then there's an in-memory format, and they're a bit different. So read, so look at the style of the coding style we use here. We put the procedure name on a new line. So if you want to find a definition of a procedure rather than a use, you search for something with the regex, with the caret, for the beginning of the line. So I want to look for read proc. Sorry, read proc. Like that, or that. I noticed that we didn't find any uses of this procedure. We went straight to the definition. That can be a little bit handy. So that's the reason for that particular style. So we read 2 passes over the code. We read the number of blocks in each procedure. That fills in this numBlocks variable. So now that we know the number of blocks, within the first pass we calculate, we allocate an array for the beginning of each block within the procedure. And then for each block, we begin reading through. We write the current offset, and we read. And for each instruction that we read, this is the loop for instructions here, because instructions can be different lengths, so we move along our counter of our current position. So when we get to the end of this loop, then we know the entire length of this block, and we can write an offset. So yeah, the editing environment Vim, it's kind of, it probably does now. You can probably get a plugin that does that lets you go to a definition quickly. I like to use C tags anyway, but it's kind of a hangover from prior stuff. So if I want to go to a definition of something, I can use C tags, which builds a database. So if I do make tags on my console, it's already done. Oh no, see, there you go. C tags, all the C files and all the H files, and that will build a database that I can use to jump to any definition. So I hit Control, close square bracket, or close curly brace, whichever that key is. I don't remember when I'm not shifting it. And it will go to the definition of something, if it knows the difference between the definition and the declaration. So, and Control T to go backwards, to go back to where you were. So you can jump around by definitions in that way as well. But it can be handy to still have that search from the beginning of the line option. Yeah, so you get to the end of this once and you've calculated the length, but without actually reading anything yet. On the second pass, so we still go around this loop. I'm going to go back to the top of the loop, to the top of the switch. Sorry, it's from outside of the procedure, is it? Yeah, we read the same. We call this a second time to actually read the procedure, and that's when we actually write the data into the code area. So that's all fine. What we actually have to change is the way calls are made. Yeah, the way calls are stored in the in-memory version of the code. Oh, and I'll show you the difference, why there's a different in-memory version from the on-disk version. So the on-disk version uses an opcode to tell you what type of instruction it's going to be, and then a couple of other bytes, 0, 1, or 2 bytes to tell you the size of the operands it's going to be working on for that opcode. The in-memory format doesn't have that. It just uses a single byte, and it has multiple in memory. has multiple opcodes for each of the on-disk opcodes, and so you've got one for add 8-bit integers and one for adding 16-bit integers and one for adding 32-bit integers. And at least that's in the current bytecode interpreter. We will have other bytecode interpreters in the future, and they might do something different, so it really doesn't matter. Anyway, we look up the instruction info. We get the width of each as we read the on-disk format. We read the opcode. We read the first width byte, if there is one, and if there's a second one, we get this from this instruction info table indexed by the opcode. If there's a second one, read it as well. So now we've got 2 width bytes. We determine if there's an intermediate value attached to this. If there is, and if it's a code reference, then we may be looking at a call instruction. I think that's the only type that can have code references at the moment. And we have to look up that in the procedures table. So it's encoded as a 32-bit number. We look it up in the procedures table. Find the procedures bytecode value, and that'll end up being an offset into the code area that we write into the in-memory format. And you might be thinking, why would it be efficient to convert between formats when you load bytecode? Other than having a different in-memory format for whatever reason, because it might be more efficient. Actually, that's a really good reason. When we get into really fast bytecode execution, we might be writing x86 or x86-64 instructions into the code area themselves. And those instructions themselves might be typically call instructions to call into some other procedure. They may be addresses of things you can execute. So of the actual instruction payload to execute. At the moment they're tokens and they're switched over, and I'll show you that in a moment. So we've found the immediate value and stored it after. Yes, this had to be a call instruction. Why do we set that? Fix up the instruction to be a C call. That's right. Because right now the call instruction can have 2 different intermediate values, and if it's a built-in C function, then we actually change the in-memory opcode to be a C call, and instead we point at the actual C procedure to execute that built-in. So this is used for built-ins. Alright. Handle the other immediate data and actually write the instruction. So now we're looking at the interpreter itself, and we check out the opcode, and for each opcode, if that one or any of these ones, and those are implemented by the macros that we scrolled past, then replace it. So if you see the instruction for sign extend that takes an 8-byte value and returns an 8-byte value, that's actually equivalent to not doing anything at all. Anyway, let's look at takes an 8-byte value and sign extends it to a 16-byte value. Then that's what we actually replace that with is a single token saying sign extend 8 to 16. So we replace all these instructions defined by what kind of thing they work on. With arguments to say what kind of thing they work on, with a single opcode to say what kind of thing they work on. Now, let's take a look at where we interpret those opcodes to look at the interpreter. I believe it's here. PZ run, the main interpreter. So we set some things up, and then while infinitely, we look at the next token that we're looking at from the current instruction pointer, move the instruction pointer forward 1 byte, and depending upon what that token is, we do the right the right operation. So let's take a look at addition or something like that. Alright, additions handled by a macro. Thank you for Rightfold for implementing these. Like, she had a really great idea to how to implement these using the macro. I don't know why I didn't think of it. So what we've got here, if we see the, let's find a better example. No, that'll do. It's just a little difficult to read. Okay, if you see that we're adding two 32-bit numbers with the add instruction, that's right. The macro does string concatenation, so it replaces all of these, any of these, with a case statement, which takes the opcode base, that's pzt add in this case, appended with, like, followed by an underscore, followed by the width. And hash just allows us to join things in the macro expansion. It will handle signedness. Yeah, all of these are signed. I'm like, why would it handle signedness for addition? That's right, we just had to pick one. So we handle signedness for the I should show you the expression stack data structure, but basically this expression stack, look at the current thing on the at the almost the top of the stack. ESP -1, ESP -1. That's right. Put onto the top of the stack the thing that's at the next top of the stack, and then the operator, in this case plus, the thing that's on the very top of the stack. And we decrement the stack pointer on the next line here, which is why this value becomes the top of the stack. So we've basically got an array to implement the expression stack here. PZ trace just allows us to do some debugging and then break out of the case statement. So basically, yeah, for each token in the instruction stream, we have a giant switch which looks at the token and does the right thing for that instruction. Where this gets a little bit funky is when we have something like a roll instruction. A roll instruction takes an immediate value of how many places to roll. So after we read this, we also have to read the depth. So that's because we incremented the instruction pointer above at the beginning of this loop. Now it's pointing at the next token. Now the next token happens to be an argument for the current token, so we read that as depth and move the instruction pointer forward once more. The depth is a byte, and it gets interpreted as basically, we just make sure that, well, roll 1 is a no operation instruction. Roll 0 doesn't make any sense. A roll of anything else performs a roll. Yeah. So when there's something else on the stack, we also, something else in the instruction, like an immediate value, we interpret it in this way. So for roll and for calls. So in this case, first we align our instruction pointer to the size of a pointer value. Take the save the return address, set the current instruction pointer to the value we read from the instruction string, and then we're done. So for a call instruction. And yeah, this isn't the fastest interpreter in the world, but it'll do for a first version. So, and it's not fast because the CPU's branch predictor can't predict the branch at the beginning of the switch statement. It is going to be terrible in that way. Alright, so now I actually want to begin modifying some things. So I'm already 20 minutes in and I haven't actually written any code. But I felt like that should be a useful explanation that stands on its own anyway. So, return stack. What I want to do, I'm actually looking at the right place here. I want to change call and call indirect so that the way that they interpret the new value is not an offset into the instruction stream. And that looks like that's already true. Yeah. Yeah, because it just sets the instruction. It's not dereference. Well, it is. It's dereferencing the instruction pointer to get the value out of the instruction stream, but it's not in turn dereferencing that and using it as an offset into an instruction block. So that means that we can make the change that I was about to make and get confused by all the compiler errors that we're going to get. I'll just... yeah, jump instructions don't matter. Return instructions don't matter at all. And... yep. I think this could work quite well. So... so I want to change the PZ module structure. Take out these two fields because they're moving into the PZ proc structure. We no longer need to know the offset because it's going to be at the very beginning of this pointer, and we can keep the new size, which is unsigned. It should perhaps be a size t value, but never mind. And we're going to get some compiler errors. Quite a lot. So, PZ on line 120. There's no point setting some default values for this, for the module, so I can remove those. 121, that's the next one. 161. Will actually be here. No, there's no sense in freeing it either. Ah, that's going to be a problem. We're going to leak memory here because procs now points to other things that we're not freeing. So we'll come back to that. Actually, I'll put a revisit. I'd rather fix all the compiler errors first. PZ module allocate proc memory. I'm going to take that all out because I don't want to. I'd rather call it on each individual procedure. So, and I don't need the module to do that for me. I'd rather do that all myself. I'm running make every time so that I get new line numbers, but I could. There's going to be a smarter way to do this. You know, I'm sure even in Vim, I just haven't learned it. Somebody said that my Vim skill. I think Bert, you said that my Vim skill was impressive the other evening. I don't think it is because I don't know how to do some things like this one. So. Module get proc code, module IE proc. Okay. I might as well The thing that I deleted, I don't know exactly. I may be keeping it. But we'll leave it out anyway. We're going to have to remove the declaration in the header file shortly, but we'll get a different error for that. So PZ module get proc code. We can return it directly. I can add an accessor function for that if I hide the details of a procedure into the implementation into the C module, which is a reasonable idea. It's going to be less efficient, but I'd rather do that and have consistent interfaces, and then later on come along and optimize it by moving that stuff back into header files and allowing it to be inlined. So, Oh, there's more than a plugin for running make. Oh, Ian. Hey, Ian. Yeah, I think I've got it mapped to F9 or F5 or something like that. So it may already. I know I had it running at some point. There we go. So no target specified. Yeah. All right. CD ... Yeah, there you go, F9. I knew I had it mapped to something. It's just been a while since I tried it. So that's cool. The copen brings up the error list. Copen, okay. Well, I think it... See, now I'm looking at error 5 of 9. No member named code size. I forget how to move between errors. You see on the status line of Vim, now you can see the error. But yeah, I don't remember how to move between them within now that Vim knows them. That's the bit I didn't learn yet. And I think F9 will save my file as well when I press it. Maybe that was another option that I added, or maybe that's automatic. I don't remember. So, it's cool to see you, Ian. It's been a while. I haven't caught up for a couple of years. So Ian makes some really cool video games for iOS. Oh no, for both platforms. For as many platforms as you can, I think. So they're worth checking out. So, my wife finds them addictive and frustrating, and so she hates Ian. Not really, but you know, the way people joke about that. So, I don't know if it preserves. This is Ian McClarty. You can find him on Twitter. I don't know if I'll just announce that because I don't know if when the video gets saved whether it keeps the chat log and that kind of information. All right. So, looking at module number of procs and code size. Well, I deleted that because I figured I wouldn't need it, but actually let's add it back because it doesn't hurt to have the total size of all the things. I just don't know how to set it yet. Hang on. And I'm going to call it total code size to make it absolutely clear what it refers to. Oh. I don't know where I'm at. Total. Does that make any code? Ah, I did that again. There we go. Yeah, okay, so it looks like I undid the change I made above. PZ module struct. I'm using C tags to move around. Yeah. Actually, let's put it here under number of procedures, because that directly refers to the number of items in that array. We should give it a sensible value when we create the structure. Number of procedures, number of procs, module, total code size. Now we're not setting that anywhere. So when we're loading code, which yeah, we'll have to fix when we change the way we allocate memory for code. Ah, I'm still, that's a funny habit. Right. See next. Type C open, C open. I'm gonna try that. Oh. Okay, so it's all the output of the thing. Is it runtime C code colon? PZ struct has no member named code offset. Yeah, I deleted that. Alright, yeah, we're looking at the next error. James, Sally, I don't remember how so what I'm doing in some cases, when I want to go to the top of a block, I'm hitting the percent sign, I think, and it's going to the matching bracket. So you can use it to check if your brackets match, and it will go to the move to the matching one. So I'm navigating a bit like that as well. When I'm using C tags, I use Control and that key, which will go to, it'll try to go to the definition of something. So if I want to look up PZProc, I hit Control and close curly brace, and now I'm at the definition of PZProc. So, which is good because PZProc has a code member that I'm not initializing it, and I should be here. Set it to null initially, and we'll fix its size later. Ah! We can remove the offset there. And the size, because we won't know them at initialization time anymore. I'm going to take an extra step. Yep, conflicting types, that's good. Ah, yeah, old habits. Right, I'm just hitting enter on each of those to look it up. So now I can remove those parameters, now that I've removed those. Create a new procedure, the offset and number of bytes. The procedure is initially empty, no code allocated. Let's also make sure that we can free procedures. Well, you know what? Ah, I see that. Yeah. We're actually going to change that as well. PZProc int is now going to return a PZProc. And yeah, like I said, less efficient, but it really doesn't matter at this point. Do I still need to do a void within the parentheses in C99? I'm going to try it without and see what happens. So, yeah, now that we're definitely using C99. And I can probably hide the definition of that. So, yes, yeah, but nice to see you. So, do I want to do that now or or in the next step? I might do that in the next step. Print F9 again. Bunch of things happened. Now what have I got? Yeah, so I still want to change this. Now, to make the definition match what I just did in the header file. And I'll show you what I mean. This is now less efficient because it now must be heap allocated. If I feel that that's a problem in the future, I'll come back and change it. And I'm fat fingering some things, which is why I'm sometimes making errors, which is just what happens. I mean, it happens to you anyway, but it happens more when you're concentrating on narrating. Return proc. So yeah, so now it has to be heap allocated, and you no longer have the option of having an array of them. So in some ways that's less efficient than what you could have had. So, like I said, you profile it later on and change it if you need to. Any more errors? No, there's the original one. No, we're all good. So F9. I see, it's already going to the first error. So code offset PZ proc. Yeah, I'm upgrading my. This is actually handy. I can get new skills just by sharing some of mine in the video. Still got about 20 minutes until I intend to log off. So I'll see how far we get. So PZProc, struct PZProc struct has no member named code offset. Yeah, I know. Yeah, so we have to refactor some stuff here. This is going to be the tedious bit. This is we're back in our reading, how to read a procedure in. So, is proc distinct from a function in Plasma? At this point we're looking at the interpreter, and so it's no longer the Plasma language. It's now the PZ bytecode format, which is created for I never explained the Z is for 0, because it was came from an older idea I had about having level 0 for the bytecode and levels progressing until you get to a higher level language, but I'm not doing that anymore. So, but the Z stuck and it just sounds cool, so why not? So what we're going... yeah, so the PZ format has procedures, but Plasma has functions, and so this is why we've got procedures within PZ. Yeah, cool. Good question. So, so yeah, so we can't read procedures based upon the offset from within that ends up getting saved in the procedure, because it won't be saved there. So read code. I'm going to go to where read code is called. I'm going to remove my error window because it's not going to help me for this bit. Yeah, so read code reads all the code. Yeah, there we are. Within the program. I believe that... Is this the... Yeah, loop over the procedures. Read each procedure. Save that information and Yeah, and then that's what I thought. Yeah, then you read them a second time with a loop that actually writes the data. So the first time you're calculating the offsets to the beginning of each procedure, and the second time you're going to read them all. So what we're going to do is turn this into one loop, because we're no longer going to read all of the procedures and then read all of the procedures once more. We're going to read each procedure twice in a large loop. And I kind of feel like at this point, you know how you do this? Watch this. Git stash. I'm going to refactor something before I begin. So we're going to undo everything I've done with git stash. It's all gone away. We're back at a working system, and I'm going to refactor something before I even begin any of that stuff. So I'm going to hide this structure. into the implementation file, the runtime pz code.c. I'm going to get a billion decompiler errors for this, but I'm going to refactor that first, and it's going to make some other things easier to do later on. The thing sounds cool. Yeah. Sure. So now we can't. Yeah. So now in the PZ file, it no longer knows the size of a PZ proc. Runtime PZC. Oh yeah. Duh. Now I can't have an array of them, but I can have an array of their pointers. So we're going to change module procs to have an extra pointer. So now these are all boxed within this array. Malloc, same deal. Oh no, that's memset. Malloc. Yeah, okay, fine, whatever. So now within a module, we need to change this to a double pointer. Now, because now it's an array of pointers rather than just an array. What else do we have? Size of the incomplete type. It's basically the same thing. Invalid use. Yeah, that was, we already fixed that one. Invalid use of undefined type. Well, that's easy. I will recompile. I will attempt to compile it again because I'm going to get different, better errors. So, PZC error request for the member code offset in something, not a structural union. Yeah. So now I'm going to have. What's my naming convention for C things? I do pz proc get code offset. Mismatched brackets. Alright, well why would it do... Oh, it's actually returning the thing to the bytes. get prop code. You know what? Get code. Yeah, this becomes simpler. I feel like we edited this already when we did the other work, but this will be easier with this refactoring, and I'll commit it separately. Module no. Oh. You know what? No, that's. I'm getting myself confused. Let's go back to here, because we do still have this code array in this version. See, proc get code offset, and in that, yeah, conjugate procs, no longer a member access. Yeah, that's what I want. Warning, control reaches of end of non-void function. No, it doesn't. Don't be stupid. There's a return statement right there, I can see it. Yeah, okay, I actually need to define the function. Duh. Might as well write the definition. Yeah, like I said, that can't be inlined into other modules in C because, well, C. But we can handle that later. So, busy broke. Redeclared as different kind of symbol. Yeah. Oh, let's do this one. Struct busy proc struct. That would be the smart thing. Ah, don't I have to put it there? I'm forgetting some C. Yeah. That would make an instance of the structure, not a bona fide structure. So dereferencing pointer to incomplete type. Yep, that's fine. That's not what I was hoping for. So PCT, this is my test case failing. So make hello.test. Runtime PC run hello.tz. I don't think I've got symbols yet. Duh. Wait. You can't put your program's command line arguments on the GDB command line. Run hello.ping. Yeah, I think I need more debugging symbols. Let's uncomment the debugging configuration here. Actually, we need to, yes. Ah, we cleaned. So I need to build the bytecode again. Run hello.pg. Proc code offset. So what have I done? In PZ code line 40. It's going to be really obvious. Runtime PZ code C40. Didn't I do that? I swear I wrote. Yeah, because of course that doesn't work. Yeah, I did that in the other version. That's fine. Thank you, debugger. That was really obvious. Yeah. So I'm going to redo a bunch of stuff that I did earlier. It's going to be tedious, but it's going to make the change in total a bit simpler. Thanks. Yeah, that change got stashed. That's right. Yeah, I'm sometimes using Control-N, not all the time. My muscle memory doesn't always know it. So, and I think it does use the tags file as well to do completion. So yeah, I'm going to end up redoing a bunch of stuff, but I think it's going to be easier to just do that. It's actually all fairly trivial stuff. I'm going to need to go back and actually write the free function. That's fine, I can do that when I get the error for it. But, need to press that button. Yeah, that's cool. What's the error? C open. What is the C for? Console? Undefined type name proc. Request remember code offset is something that's not a thing. Yeah, because I got the type wrong. This bit will need to refactor now. PC broke again. So that used to return the slot of the array to us. Now we're going to set a value into the slot of the array with set proc. And other than that, I think it's all good. Same error. Too many arguments to function. Yep. Declare. Yep. Yeah, because I haven't defined it yet. Okay. So I need a set proc method. I'll put it next to the get proc method. So it's about 2 minutes to 10. I told myself I'd finish up at 10. So if there's any last questions, I'm happy to answer them. And then I'll, finish streaming. So I hope you all have a good night. I hope this was interesting. I think that's the best I can hope for. So, and yeah, let me know if you want me to do this again. I think it's not terrible. So to do this again. Oh yeah, the source is online. There's a link to the website in the description. I think so. Let me just check. Well, actually, in the last few minutes, let's go check out the website. And some of the source code and find some links and things. So if I switch to full screen on my OBS Studio program, let's just check that worked. Did that work? Are we in full screen mode? Yes, we are. Good. So the Plasma language is what I'm working on. It's plasmalang.org to go to the website. I haven't posted anything for a while, but the idea was to write blog articles here and on my own site about monthly, or maybe less often here, mainly for announcements. What I want to show you is the roadmap. First, I was going to show this at the beginning of the screencast, but this is where I'm at with the project. We've got something that can do Hello World. We've finished that, and I'm now working on the language groundwork phase of the project. And I've been at this for 2.5 years, and it'll take a few more to get to where I want to take it. So I've got some basic syntax, a fair amount of the type system, that took quite a while, some of the resource system, which I can describe in a future video, some more stuff. So what we're working on now is environments for closures at runtime. That's what I've been working on tonight, is some refactoring to prepare for that. It's going to support more concurrency and parallelism. It's going to be quite ambitious with that, based on some of my earlier work. And there's heaps of cool future ideas as well there. But yeah, so you can check out the roadmap and get a sense for where the project's at. If you go to, I think it's contact, where there's the Twitter, everything's here on the contact page. The main communication, although it's fairly quiet, is the mailing lists. IRC tends to be a bit more vibrant. Plasmalang on Twitter, GitHub, blah blah blah, and a link to my own site and who I am and what I've done before is there as well. If we go to GitHub, so all the sources here in Plasmalang Plasma. It's totally open source. It's an MIT license. Feel free to contribute. If you are contributing, check out the contributing file, the contributors information file here. It tells you just in brief what you need to know, and then some specifics about how to actually go about it. If you feel like joining in, plenty of open issues, and we've had some quite recent contributions. So it's fairly exciting at the moment, the phase we're in. Oh, and if you're wondering why the colors are all weird in my browser, it's so I can read it with my poor eyesight. So that's a thing. Alright, I think that's about it. I'll finish up and say goodnight. Yeah, I hope this was interesting, and yeah, let me know if you want me to do it again. Catch ya.